Hello, I am Arnav Das. Today we come together for discussing the new topic, that is the information channel. Physical transmission medium over which the information is transmitted from the transmitter to the receiver, basically known as information channel. They are broadly classified into the two forms. One is the continuous channel and another one is the discrete channel. For the continuous channel, input and output as a form of the analog electrical waveform. That means it is the continuous manner of input signal which is come at the output side also. But if you consider for the discrete channel, that time input and output in the form of the sequence. That means it is the discrete pattern of signal will be used for the transmission section, and the receiver section we got it the discrete one signal. So this is the discrete channel. Basically, channel act as a filter to the incoming signal due to its non-linear behavior. If it is adding or multiplying the signal with the random growth. So here the random error is introduced and also the blast error can be introduced on there. So obviously there's some limitation is going on there for then that particular channel. The ultimately the channel error will limit the maximum data rate at which the data can be transmitted over the channel. So channel error is an important term for analysis the information channel. For an acceptable bit error rate, there is a maximum rate at which the data can be reliably transmitted over the channel, basically known as channel capacity. Now we discuss little bit about the channel mode. For the channel mode, there firstly come up that a discrete memoryless channel or DMC, which completely described by the set of transmission probability and which is defined as P sub P within bracket y of j slash of x of y, where y is defined the output and x is defined the input one. So that particular channel, there the input combination is I number and j is defined the output number, how many the output is present for that particular system. Conditional probability, or also named as a channel transmission probability, is defined as a form which also defined as a p suffix of j of I, where I is defined the source and j is defined the destination. So p of ji, if they are written as a p of 2 1, that time we are considering their I as a 1 and 2 is considered for the j. That means output side 2 is connect with the input side of 1. So that means the probability is due to the reason of input channel 1 and output channel 2 on there. This is basically as a form of the matrix 1, and that one is defined as a probability transmission matrix or PTM, also known as channel matrix or simply channel matrix or noise matrix, where row are defined by using the x into the form of this one, and column is defined by the output one, that is y1 to up to ym if we consider the m number of output terminal is present on there. So from this discrete communication channel diagram, you can able to identify here this section is defined the input, this section is defined for the output, and where the noise is introduced one. By a simple example, I think it will be better for understand. Consider a discrete memoryless source DMS having the input alphabet x1, x2, and x3. That means their number of inputs are the three, and the output alphabets y1, y2, y3, and y4. That means total one is the four on there. So when or how the discrete communication channel will be? Here it can be form of diagram as such, but there's little bit mistake is occur on there. You just look carefully. Here p suffix of 1 1 means y1 output terminal will be connect with the x1 because p suffix of j of I, where I is defined the source and j is defined the destination. So in this case, p suffix of 1 1, here source and destination both one is defined as a 1. So this is correct one in here. For the p of 1 2, here source is 1 and 2 is as a output, so this is not the correct one in here, so please correct this one. This will be named as this one will be named as a p of 2 1 because 1 is the input and 2 is the output on there. Same way for this one p of 1 3, this is also not the correct, so this one will be represent for that particular arrow, it will be represent as a p of 3 of 1 for this one. This is not the correct one. P of 1 4, this is also not the correct. This will be named as a p of 4 1 for this one. And same way you just correct this total one diagram. This is for my mistake, I just write down the wrong one on there. So we just recall in here by simple equation form, where p of 1 1 will be defined as a p of y1 by of x of 1 due to both of the input and output is 1 on there. For the p of 1 2, that this is the y1 is the output and 2 is the input, so this is the correct. And for the 3 4, it will be 3 as the output and 4 is the input on there, so the matrix form will be as such. If you consider the 2 3 position, that means x3 is the output, so this is 3 is the I and y2 is the input, output, so 2 is the j on there, so this is written as a p of 2 3. Now p suffix within bracket a of b is the joint probability of ab. In this case, if a is defined as a xi and b is defined as a yj, then ab will be defined as a p of ba dot of p of a. So in here, if you write down as a form of joint probability, then p of xi comma of yj will be written as a p of yj by of xi dot of p of xi. So here the modified version of this one will be written as such. So if you convert the probability uh, of that particular matrix, that is the conditional matrix, you are convert into the form of the joint probability of input and output, that is the a and b, that the matrix will be look like this one. Okay, so sometime it is required for the mathematical calculation time, so it will be required to memorized. Now the next one topic is that joint probability matrix or JPM has the following property, that is the summation of I equal to 1 to n, the joint probability of xi and yi, it should be equal to p suffix of p within bracket of y of j, p suffix of x. That means if you want to get only the probability of x of I, that time you can collect the value by using that particular expense. This is so important one. You just memorize this one for the mathematical point of view. If you want to get the summation of probability of x of I, and that one should be equal to 1. That is, sum of all element of a JPM is equal to unity on there. So thank you for today's class and thank you for listening this lecture. Have a good day.